Hey guys, so last time we talked about when we're dealing with e to the x, and we talked about how to find the derivative of e to the x. We talked about how to find the derivative of natural log of x, and if you had something in there like x squared, and we talked about chain rule and things like that. We talked about integrating. Well, everything we did was base e, right? Like we had a base e. When we have natural log, we have a log with base e. Everything was base e. Today is kind of all that same stuff, but instead of base e, it's what if we have exponential functions that are other than base e? And so we just have a few rules to learn. We don't have a very lengthy lesson, but we just have a few rules to learn. So the first one is, let's say we want to find the derivative of a to the x. If you look over here, this example, like if we wanted to find 7 to the x instead of just e to the x. Well, remember the derivative of e to the x is e to the x. Well, with a to the x, it's pretty similar. The derivative of a to the x is a to the x. But then we have to multiply by the natural log of whatever the base is. So this is just a rule we're going to have to know. The derivative of a to the x is a to the x times the natural log of a. And you've actually been doing this even with e. If I said find the derivative of e to the x, it would be e to the x and then times natural log of e. The reason we don't do it with e, though, is because the natural log of e is just 1. And so that just turns out to be e to the x. So we've really been doing it every single time without knowing it. Okay, so if I want to find the derivative of 7 to the x, it's 7 to the x, and then times natural log of 7. Pretty straightforward. It's not a very difficult rule, just one that we have to remember. Well, let's say it was something other than just x. I have this example here. What if it was 2 to the 3x? So if your exponent is a function of x, well, then it's going to be a to the u times natural log of a, so same thing. But then we have to apply chain rule and multiply by the derivative of u, so u prime. And we've been doing that with e to the x also. So over here, it would be 2 to the 3x times natural log of 2 times the derivative of the exponent, which is 3. And that's it. You could put the 3 out in front or whatever you need to do, but that's our derivative. Last time we talked about the derivative of natural log. What if it's a log of something other than base e, so base a? Well, here's our rule. It's going to be 1 over x, just like the natural log of x was. Now here we need to be careful. We are again going to multiply by the natural log of the base, just like the exponents, but it goes on bottom of the fraction. So you're not multiplying the whole fraction by natural log of a, you're multiplying the denominator by the natural log of a. And that's what's going to happen over here. So the derivative is going to be 1 over x, and then times the natural log of 7. And that's our derivative rule with logs other than base e. And then we do integration. Very similar. So when you take the derivative of e to the x, it's e to the x. And remember, when you integrate e to the x, it's e to the x. And most times when you're integrating, you're going to have u substitution. So the integral of e to the u is e to the u plus c. So we learned that last time. Well, when it's a to the u, the integral of a to the u is a to the u. But when we did derivatives, we multiplied by the natural log of a. Well, when we're integrating, we divide by the natural log of a, and then plus c. So it's very similar to the derivative, except instead of multiplying, we are now dividing. So if I want to find the integral of 2 to the x, it's 2 to the x divided by natural log of 2 plus c. So we have a pretty messy one here, but remember, when you guys are integrating, always have u substitution on your mind. I'm not going to say, u substitution is what you're always going to be doing, but always have it on your radar. So if I had sine of x be u, the derivative of it is cosine of x, and I see that show up here, prime candidate for u substitution. So I'm going to have u be sine of x du is cosine of x dx. And I always stop here and look at my substitutions. So I would have 3 to the u, and then cosine of x dx is just du. Look at how nice that turned out to be. And then we just apply our rule from above. So it's going to be 3 to the u divided by natural log of 3 plus c. And then I'm going to replace what u is back in for it. So it'd be 3 to the sine of x divided by natural log of 3 plus c. The very last one, it kind of has nothing to do with this lesson. But so a couple years ago, after my students took the AP test, you're not really allowed to tell me what's on it and stuff, but they came back and they said there was a there was a problem that said, it asked for this. And they said they thought it was asking for like the 6th power. Well, in derivative notation, and so I wanted to add it to this note so it's something we talk about. In derivative notation, it's y prime, y double prime, y triple prime. But after the triple prime, they start putting in numbers to represent what derivative it is. So it'd be like the 4th derivative, the 5th derivative, and so on. So I just wanted to put this problem on here to talk about notation that you might come across, because we haven't really talked about it. So this is saying find the 4th derivative if y equals sine of 2x. That's all this is saying. So I'd first start by doing y prime. I also added this one to remind you guys of chain rule with trig. It's been a while. So remember, it's derivative of the outside. Inside stays the same. Times the derivative of the inside, which I'll put out in front. And then I just kind of repeat this process. So the second derivative is going to be, let's see. So the derivative of cosine is negative sine. Inside stays the same. I should have put the 2 out in front. That's my bad. So notice I keep that 2, and then I just put the negative in front. But then I have to multiply by the derivative of the inside again. So it'd be negative 4 sine 2x. Y triple prime, well, if you think ahead, you're going to be multiplying by that 2 on the inside. So it's going to be, and the derivative of sine is cosine. So it's going to be negative 8 cosine 2x. And then the 4th derivative, well, cosine's negative sine, so it's going to be positive 16 sine of 2x. But my main goal in this one is reminding you guys of chain rule and just talking about that notation. All right, you guys have a short assignment. Peace out.